Is Toolpath important to you? Is getting your toolpath right important to you? Then SmartCAM is the CAM solution you need. Only SmartCAM provides you total toolpath control of the entire machining process. Today, I'm going to provide a short demonstration of some of the solid machining functions delivered in our SmartCAM advanced turning solution. Machining from solid model data is increasingly important in today's manufacturing business. Our solid machining tools enable the SmartCAM programmer to create roughing and finishing toolpaths directly on solid model features without the need to extract wireframe geometry from the model. This demonstration will show you how easily you can generate toolpaths from solid models using SmartCAM and how it gives you unparalleled and complete control over your entire machining process as well as the resulting NC toolpath. We will generate rough turning toolpath for the front region of this carrier arm component. Cross-sections of solid model components often have features such as flats, bosses, pockets, recesses and holes which interrupt the cross-section in the ZX turning plane required to generate correct toolpath. This is particularly true of components being machined on turning centres with C-axis and live tooling. On this component, we can see that a drilled and countersunk hole interrupts the ZX plane turning profile, and also that the greatest diameter that needs to be rough turned does not lie in the ZX cross-section. We will use SmartCAM's solid turning functions, available on either the toolbar or on the menus. SmartCAM provides linear and contour roughing, grooving and profiling options for roughing, semi-finishing and finishing processes. SmartCAM's solid turning cycles can be used to generate turning and facing, back turning and back facing, and external and internal groove toolpaths. Here we will demonstrate the use of the linear roughing cycle. We will use a cut depth of 0.15 inches and a cut pass angle of 180 degrees. The default pass angle is calculated according to the orientation of tool insert in use and the user selected option of facing or turning toolpath. Any specific pass angle can be easily manually input as required by the SmartCAM programmer. The programmer has accurate control over the positioning of the slice profile used to generate toolpath. An angle or coordinate position can be used to define the precise radial location. Let's use the radial point method and select the coordinate of a point from the model at the position we require. The stock boundary, used to limit the extent of roughing cycle toolpath, can be defined in three ways. Using a ZX coordinate at the extent of a solid billet, by selecting a stock profile in the case of forged, cast or staged machining billet, or simply by allowing the extent envelope of the solid areas being machined to define the stock ZX limits. Let's use that last method in our example, selecting the part profile option. Next, we define the region of the solid model that we want to machine using SmartCAM's powerful group selection tools. For this roughing cycle, we limit the selection to the area we want to machine by first selecting our required start and end surfaces of the model, and then using the Add Adjacent selection to add the chain of surfaces that lie between them. We pick the first surface, the chamfer on the front of the component, then the last surface we want to machine, and automatically add the chain of surfaces in between using the Adjacent Neighbours selection mode. Hit the Go button and the toolpath is quickly generated exactly as we wanted it. The complete cycle, along with all of its parameters, is contained in just a single element, called a process container, in the SmartCAM model file. SmartCAM process containers can be edited at any time to modify parameters or the extent of the model being machined. The SmartCAM user at all times has total control and is able to generate toolpath to exact needs. We can clearly see the linear roughing cycle in the ZX view orientation. Back to the isometric view of the model, and we will create further linear roughing toolpath for a facing operation from the solid model data. We select just the single front face of the model, which is at Z0. This time, we will use a stock point to define the material boundary to be used by the cycle. We will use a distance of 0.2 inches in the Z direction and continue with a pass depth of 0.15 inches, which will automatically create the multiple passes we require. We use a stock diameter of 3.5 inches, just beyond the maximum diameter of the chamfered face. We hit Go and facing toolpath is generated. Notice that the minimum extent of the toolpath has been correctly generated to the extent of the inner diameter of the front face. It is often required to extend toolpath beyond the limits of the solid region being machined, either at the start or end, or sometimes both. Let's show you how easily the user can do so by extending the toolpath on our example to the X-center line. Simply undo the previous toolpath, then modify the parameters before regenerating. The Part Profile tab of the dialog contains the options for extending the start and end of toolpath. The programmer can choose to extend the toolpath tangentially or in any of the primary axis directions. The distance by which the toolpath is extended can be controlled by either a specific incremental amount or by defining a point which will generate an intersection position on the extended toolpath. In our example, we will use the intersection point option and select a position at Z0x0 in order to extend the toolpath to the center line. A second process container has been added to the database. You can easily resequence or modify the position of any SmartCAM toolpath element or group of elements. For example, the facing operation can be positioned before the rough turning. Finally, we switch once again to the ZX view and use Showpath Toolpath Verification to simulate toolpath motion in wireframe. SmartCAM Showcut Verification is used to simulate machining with material removal from the stock, which can be generated from wireframe or a solid model. Today we have demonstrated the solid machining capabilities of SmartCAM Advanced Turning. There are further video demonstrations detailing more features of SmartCAM products available on our website www.SmartCAMcnc.com. SmartCAM lets you quickly and easily generate roughing and finishing toolpath for your solid features without needing wireframe geometry, delivered with the classic SmartCAM trademark of providing you complete control over your toolpath. If the question of how to control your toolpath is important to you, SmartCAM is your answer.